Talk about solving right triangles. And eventually what we're going to get into is when we talk about solving a right triangle, we're going to talk about finding all the missing parts of this triangle. Well, for this problem here, we're not quite getting into that point. We want to find the sine, cosine, and tangent of theta. Now, theta is a symbol that we use in trig. It's a just something we use a lot of times for an angle measure. It's a Greek symbol. And so instead of using x or something else to label this angle, we're using theta. So it's just a different symbol. We won't see that a lot in geometry, but when you get to trig, you'll see that a lot more if you take trig. Okay, so first of all, what would I do if I wanted to find out what x was here? How could I find x based on what we know from this chapter? What's something that we could use? When I know two sides of a right triangle and I want to find the third, what'd you say? Not quite SOHCAHTOA. In order to do SOHCAHTOA, we would need to know what the angle is first. Okay, and I just want to find x first. What was the very first thing that we did in chapter 9? Been a week and a half or 2 weeks ago. Pythagorean theorem. Good. Okay. Okay, so we got A, B, and C. And remember, the A and B are interchangeable. Doesn't matter which one's which. So we're going to go 7 squared plus B squared equals C squared, which is 10. Okay, so this is 49. 100. Subtract 49. And we take the square root. Okay, now here's the part that's a little bit weird, is we are, not weird, but this is the length of my side. That's the exact form of the length of this side. Now, if I was doing like a story problem we've talked about, we'd probably go to a decimal here. But for right now, we're going to leave this side as the square root of 51. Okay, we could try to break it down, and we could see if it simplifies. Is there anything that goes into 51? Three does, okay. Which would be 3 times 17, okay. Can I break 3 or 17 down anymore? No. Okay, so even though there is something that goes into 51, there's no pairs, so we can't simplify it any further. So that's why we would go ahead and write it as radical 51. All right, so now the big question was, what is the sine, cosine, and tangent of that angle? Okay, so we got sine of theta, cosine of theta. Theta is kind of a 0 with kind of a line through it. And then we have tangent of theta. Okay, and once again, last week we talked about knowing how to spell SOHCAHTOA. Okay, that's going to be extremely important next week when we take the test. And then know how to use it, right? So if I'm going to do sine, we're going sine from theta. Theta is this angle right here. So this is our reference angle. This is the angle we're going to. So from this angle, sine is opposite over hypotenuse. So we probably want to label the 3 sides. Opposite, adjacent, and hypotenuse. This is my angle of reference. This is across from it. This is adjacent to it. And then this is my hypotenuse because it's across from the 90. Okay? So be careful when labeling because how we label that is everything. Okay, so sine is opposite over hypotenuse. So this is my opposite side. This is my hypotenuse. So we would simply just say 7 over 10. We don't do anything to solve it. We're just looking for a ratio. Cosine of theta. Once again, here's theta. Cosine is adjacent over hypotenuse. here's my adjacent side, here's the hypotenuse. So we would go radical 51 over 10. Okay, is it okay for me to leave my answer like that? Yeah, it's okay to have a radical on top. It's not okay to have a radical on bottom, so that's as simplified as we can get. For the tangent, tangent is opposite over adjacent. So here's my opposite side, here's my adjacent side. So we're going to do 7 over radical 51. Is it okay for me to leave that ratio like that? No, we can never leave a radical on the bottom. How do we get rid of the radical 51 out of the bottom? Multiply by that same radical. So this would become 7 radical 51 on top. You can't multiply those numbers together because one's inside the radical, one's out of the radical. And on bottom, when I take radical 51 times radical 51, I get 51. It doesn't really look like it's simplified, but it is simplified because 7 and 51 don't reduce. There's nothing else I can do to simplify that. That's my answer, or all three of my answers. I'm not going to do the one on the right because it's basically the same idea, and I just want to save some time. Okay, so all that does is that just kind of is just a repeat and kind of a refresher of the things that we did last week. Writing the ratios, reviewing what sine, cosine, tangent is, and being able to apply them to write a ratio. Okay, last week we did a little bit of solving. We were trying to find missing sides based on an angle that we were given. The reason we can't use trig on this one is because we don't know what the angle is. But today we're going to talk about solving a right triangle. Well, there's one thing that we did not do last week. Last week we talked about finding missing side lengths. We did not talk about finding missing angles. Okay? So, determine which of the two acute angles has a cosine of 0.5. So here's the first thing. Cosine of something, I'm going to put a blank here, equals 0.5. Well, 0.5 can also be written how? 1/2, right? 1 over 2. Cosine is, I'm going to write it up here again. I know I have it at the top, so if you already have it on your paper, you probably don't need to write it again. Cosine is adjacent over hypotenuse. We already have the ratio, but that's why we want to write it as a fraction and not a decimal. They wrote it as 0.5. 0.5 and 1/2 are the same thing. 1/2 is better to get our ratio. We always want a ratio here. So what angle is adjacent to this side and the hypotenuse is 2? Well, the hypotenuse is always going to be 2. So which angle is adjacent to 1? B or A? Okay. Okay, so if I go from B, this would be the opposite side. This would be the adjacent side. If I went from A, this would be the opposite. This would be the adjacent. Okay? So we want, this is adjacent. And this is the hypotenuse from B. So we would say the cosine of B equals 1 over 2. Okay? That's all it's asking us. Determine which of the two acute angles has a cosine of 0.5. My answer is either A or B. So you might say, well, it's 50-50. But we got to kind of process and figure it out based on what we've got. Okay, so here's, once again, how we're going to write it. Sine of something equals 12 over 13. It gives me the trig function. It gives me the ratio. I have to figure out which acute angle. So my answer here is either E or F. It will never, ever be the 90-degree angle. Which acute angle has a sine of 12 over 13? Well, in order to be sine is opposite over hypotenuse. Okay, so we already know this is the hypotenuse, but we need this to be opposite because we're using the sine function. So which angle is opposite of 12? Is E or F opposite of 12? E, okay? E is across or opposite of 12, okay? So E is the angle that we want. I wouldn't want to put F here because 5 is opposite of F, okay? And so we got to decide, first of all, is it sine or cosine, and which side are we using? And then the last one, tangent of something equals 5 over 12. Okay, tangent. Tangent is TOA, right? Opposite over adjacent. So from which angle are 5 and 12 opposite and adjacent? So it's got to be either E or F, right? So if I just went to E, what would be opposite of E? 12, okay? So if I did opposite over adjacent, that would be 12 over 5. So E doesn't work, right? If I went down here to F, this would be opposite, this would be adjacent. If you want to label them, you could. This would be opposite, and this would be adjacent. And so it would be from angle F. So we're using the trig function and the ratio that we're given to figure out which angle that we're talking about. Okay, the reason that's a big deal is because today what we're going to do is we're going to find missing angles. We didn't have any problems like this last week where we were trying to find the angle. And we're still going to use our calculator for this, but we're going to use it in a little bit different way. Okay? We are going to do, we call this the inverse. And there's 3 different buttons that we're going to use today. And we use this button whenever we're trying to find an angle measure. Okay? And so we call that the inverse tangent, the inverse sine, and the cosine inverse. Okay? So the inverse button finds angle measures. We only use this button when we are looking to find angle measure. And it depends on which angle we're trying to find and which ratio we got. Right above, for most of your calculators, right above sine, cosine, and tangent, you see it says sine -1, right? So in most of your calculators, what you're going to have to do is either hit shift or second to get to that -1 button. You can't just hit normal sine, normal cosine. You got to hit shift or second, depending on the type of calculator that you have. All right, so we're going to do one of each with us. We don't have a ratio here given, but we don't necessarily have to have a ratio. They just give us a decimal. I'm looking for an angle measure. So in this case, the way I'm going to type this one in, I'm going to do the tan -1 of 0.75. And once again, it kind of depends on the type of calculator you have. So if you don't have your calculator out, get it out and try putting this into your calculator. For part B, we're going to do sine -1. Thank you. And for part C, we're going to do cosine -1 because that's the function that we're using. Okay, so try putting all 3 of those in. And we're going to round to the nearest tenth, first decimal place on all 3 of those. If you need help with the calculator, let me know. You got your calculator out, guys? Okay, have you tried putting this in yet? Anybody need help with the calculator? Okay, the 3 answers that we get here. We're looking for an angle measure, so my answer should be in degrees. So A is about 36.9. B is about 60.5 degrees. And C is about 81.4. Okay. Those are the 3 that you should get. And those are just strictly plugging it right into your calculator problems. Okay? Anybody need help with their calculator on that? Everybody's able to get those okay? Okay, I think I'm going to skip these next three because those are just, once again, just calculator problems again. We're looking for an angle measure, and with those are just plugging it right into your calculator. Okay, so here is really the big part of what we're going to be doing today. I'm going to put a big star by this, okay? Every triangle that we're given, we're going to be given a little bit different information. And when it says to solve the triangle, what it's asking us is to find all the missing pieces of the triangle. What are the missing sides? What are the missing angles? And we can use anything that we've used so far in this chapter. So that means Pythagorean theorem. Maybe we're going to use it. Maybe not. Depends on what we're given. Okay? I could use possibly a 30-60 or a 45-45-90 triangle, but we probably won't see those today. Okay? So probably not. And then we could also then obviously use trig. Trig's going to be a really big part of what we're going to do today. But I'm just telling you that Pythagorean theorem is probably one of those things that we could use today. And that's why we did that first problem together, because it's been a while since we did a Pythagorean theorem question. All right, so in this case here, we have a triangle, and in a triangle we have 6 pieces, right? We have 3 sides and we have 3 angles. I have to find all the missing pieces of this triangle. Anytime it says solve the right triangle, we're finding all the pieces that are missing. Okay, now I'm going to tell you this real quick because this is kind of important. Big letters are used for angles. Little letters are used for sides. So if this is angle A, the side across from angle A is little a, lowercase a. If this is angle B, the side across from big B is little b. Okay? And that's how usually they're going to be labeled. They're not going to usually be labeled with an X or a Y. They're going to be labeled big B and little b. Big letters are your angles, little letters are your sides, and it's always across from each other. All right, so first up, we want to find little c, okay? Missing side. Right now we know 2 sides. What would I do to find c here? We just did it here about 5 minutes ago. Pythagorean theorem. If you are given 2 sides, we can always use the Pythagorean theorem to find the third, as long as it's a right triangle. But everything in this chapter is a right triangle. So we're going to go 3 squared plus 2 squared equals c squared. 3 squared is 9. 2 squared is 4. 9 plus 4 is 13. So the third side is the square root of 13. Okay, that's something that we've done before. That's not really new. So we now know all 3 sides, right? And we're always going to leave it, unless it says round to the nearest tenth, like I know it says round to the nearest tenth here, so then I could put that in as a decimal. But most of the time, sides, we're going to leave it as a simplest radical form, okay? And just pay attention to big ideas today. And if it doesn't take radical 13, then just put radical 13 into your calculator and you can change that to a decimal pretty quickly. Okay, now, angles. We have 2 angles that we have to find. We already know there's a 90, but all of these are going to be a 90. Okay, so that's one thing that will not change. We have to find A and B. Okay, and if I knew one of them, I could find the other one really easily. Okay, but in this case, I don't know either one. Okay, so I got to find one of them, and then I can, if I know one, I know the other. Because in this triangle, we know we got 180, right? And it doesn't matter which one you find first. Okay, I can either find B first or I can find A first. So you get to choose. Let's say I wanted to find angle A first of all. So if I go from angle A, you have three options here. You can use sine, you can use cosine, or you can use tangent. It doesn't matter which one you use. Now, if it was me, I would pick out the one that's the easiest to use. And the two that I'm going to choose to use here are the opposite side and the adjacent side. Why am I choosing the opposite side and the adjacent side? What's better about those sides than my hypotenuse? If I looked at these three values, 2, 3, and radical 13, what would be the best numbers to use? Yeah, the nice whole numbers, right? So that's why I'm choosing, let's use the opposite and adjacent. Let's not use the hypotenuse because it's a radical or a decimal. We don't really want to do that, okay? So, opposite and adjacent. Go ahead and at the top of your paper, write the 9 letters again. Okay, so Katoa. The two sides that we're going to use here from angle A are opposite and adjacent. So which trig function are we going to use? Which trig function uses opposite and adjacent? Tan, right? O and A. Tan is O and A. So tangent is the trig function we're going to use. So the way we're going to do this is we're going to say the tangent of A. We're always going to put the angle next to the trig function. The tangent of A equals opposite over adjacent. How you write this ratio is extremely important, okay? You can't just choose whatever order you want to put them in. This comes first, this comes second, so this goes on top, this goes on bottom. Opposite over adjacent, always. So 3 over 2. Once we get to this point here, now we're going to use our calculator. We've got to write the equation out first. And this is what we did just a second ago. Anytime that I'm looking for an angle measure, I'm going to use the -1 button. Okay, what do we get for A? 56.3. Okay, and that would be A. Okay, now, if I wanted to find B, the easy way to find B is to subtract it from 180. I just want to show you this real quick, okay? If I wanted to find angle B, then I could also do a trig function. I could do the tangent of B. And if I go from angle B, now this one is opposite and this one is adjacent. Okay, so those two are just going to flip-flop. So I could do the tangent of B equals 2 over 3. And so if I wanted to put it in my calculator, I could do the tangent of -1 of 2 over 3. Okay, what do we get there? Okay. And the reason I show you this is because if we add these two together, what do we get? What should those two add up to be? It should have to be 90, right? We already had a 90-degree angle, and these two should add up to be 90 as well because we have a total of 180 in that triangle, right? So these two should always add up to be 90 degrees. If they don't, I've done something wrong. Now, once I got to this point, I could have just taken 90 minus this and it would have gotten me here. And I don't have a problem if you do that, But here's the issue with doing that. If I do 90 minus this, and let's say this is wrong, then I'm going to miss this one too. Okay, so if you miss this one and you don't do a second equation, so one of the good things about doing both equations, it doesn't take that much time, but then you can verify that the two add up to be 90. Okay, I don't have a problem if you take 90 minus this, especially if you're 100% positive this answer works, but you just got to be careful about that. Because if you miss the first, you're going to definitely miss the second. Okay, let's jump down to this one here, okay, at the bottom. Okay, how many sides do we know right now? Two, okay? So if I know two sides, what's the best way to find the third side? Pythagorean theorem, every time. But here's where you got to be careful with the Pythagorean theorem. Okay, on this one, I'm going to label it little g, little h, little j. Okay, just use this lowercase letter for each one of those. Just so you get in the habit of doing that. I want to find little h. We always labeled the sides A, B, and C, but the important thing here is that the 109 is your hypotenuse. So what we're going to do here is we're going to say 91 squared plus h squared equals 109 squared. Okay? And you might say, well, why do we have two different letters here? I just put B in here because that's A, B, and C, Pythagorean theorem. So you can either put H in here or you can put B in here. If you want to put B in there, that's fine. But it's probably going to be labeled H, like what is the value of H? So H is probably going to be better to put in here. All right, so the best way to do this, and you can write the whole equation out if you want to, but just thinking through the process of solving this, I would take 109 squared. If you wanted to put this all into your calculator all at once, I could do 109 squared minus 91 squared, because I'm going to subtract that from over here, and then I would take the square root of it. Okay, if you want to do it all in separate steps, you can, but you can also do it all together here. So let's try putting that into our calculator. Let's see what we get for H. Darson, what'd you get? You need to pay attention to what we're doing up here. Why don't you close your computer and pay attention to what we're doing, okay? So you know what's going on here. I know. That's why I want you to close it, because you're not paying attention to what we're doing here, so then you're going to be lost when we get to this. Okay, anybody get it? 60, okay? And it's not always going to be a nice whole number, okay? It's nice when it works out to be a nice whole number. Everybody able to get 60 there, okay? It's just doing the Pythagorean theorem, okay? So that shouldn't be too big of a deal. Now, I want to find angle G, and I want to find angle H. Okay? Angle G. And it really doesn't matter which one we find first, okay? You get to choose. Bless you. Let's go from angle G, first of all. Okay, and I can use any of the three sides that I want to use, okay? It does not matter which trig function we use because we now know all three sides, right? So let's go from G. And because all three numbers are pretty nice whole numbers, there's no decimals, there's no fractions or radicals or anything like that. So pretty straightforward, okay? You can use any of the three sides. Okay, but let's use one that we did not do on the last one. On the last one, we used tangent. Okay, so let's either use sine or cosine here. Let's just use the two that they gave me here. Okay, I'm going to use the two that were given to me from the very beginning. That way, especially if I made a mistake here, then I'm not using the wrong number. Okay? There's nothing wrong with using 60, but I'm going to use the two that were given to me. So from angle G, 91 is opposite. 109 is the hypotenuse. Okay? So we have O and we have H. Which trig function uses O and H? Sine. Okay? So we're going to go sine of the angle, which is G, equals opposite, which is 91, over hypotenuse, which is 109. Okay. Any questions on how to set up that equation? We did a little bit of that last week. Because we're finding an angle measure here, we're going to do sine -1. So we're going to do the sine -1 of 91 over 109. Okay, what's that give us for G? Okay, 56.6. Okay, and if I really wanted to then, I wouldn't necessarily have to do another trig function. I could just say 90 minus 56.6, and then that would give me 33.4. Okay, you could set up another equation, but sometimes I know that takes a little bit of time. Okay, but if you're not 100% sure about this answer, set up an equation here and see if these two add up to be 90. These two always have to add up to be 90. Always. Every single time. Okay? But once again, it does not matter which trig function you use on something like that, because I have all three sides given to you. There will be times where it matters which trig function we use. But if we already know the side, all three sides, then we have options. Okay, questions on any of that? So when it said solve, we have now found all three sides and we found all three angles. Okay? The 90 is the angle that's always going to be given to you. But you have 6 pieces that we are going to finish with. Okay, a little bit different example here. Once again, the directions are the same. We're still solving for the right triangle. Round to the nearest tenth if necessary. Okay? Can I do the Pythagorean theorem here? No, because we only know one side. I don't know G and I don't know H. So that's out. Okay? And once again, notice how opposite big G is little g, opposite big H is little h. We would call this little j. They have it already labeled as 13, so they didn't put j there, but if we had to label it, we would label it little j. We'll go ahead and put that here. Okay, what would be the easiest thing to find? We have 3 pieces that we need to find. We have little g, little h, and what other piece do we have to find here? Angle G. Good. Okay. Angle G should be pretty easy here. Okay? Because what do we know about the triangle? All the angles add up to be what? 180. Okay? And we already know this is 90. So that's taking 90 out. So really simply, to find angle G here, all I got to do is take 90 minus 25. So angle G is 65 degrees. That's the easy one. And if you wanted to go ahead and label it, you could. Okay, so that's the first piece. It all kind of depends on what I'm given as to which part is best to find. Okay, now let's say we want to find little g. It doesn't matter which one we find first. What I would do here is I would use, and this is kind of what we did last week, I would use the angle that we were given, the side that we're trying to find, and the side that we already know. Okay? I would use the information that is given to you. Could I use 65? Sure, I can use 65, but I would probably rather use the angle or the pieces that were given to me. okay? Just in case I make a mistake or something. So from 25 degrees, what side would little g be? Opposite, adjacent, or hypotenuse? Here's 25. What side is little g from 25? Adjacent, okay? So that's going to be our adjacent side. What about 13? Opposite, adjacent, or hypotenuse? Hypotenuse, because it's opposite the 90. Hey, once again, we keep coming back to this. This is what I told you last week. We're going to use this over and over and over again. You got to know how to use SOHCAHTOA. We're going to use it so much that I'm probably not going to give it to you on the quiz or the test next week. You're going to need to write that at the top of your paper very first thing, because I want you in the practice of knowing how to use it and how to write it. Okay, so we have adjacent and hypotenuse. Adjacent and hypotenuse is cosine, right? So we're going to go cosine of the angle equals adjacent over hypotenuse. We know the angle, we know the hypotenuse, we're looking for the adjacent side. That's the piece that's unknown right here. Yeah, Berkeley.
Does 25 go with the H though, instead of G?
Oh, it goes with,
Because 25 goes with the little h instead of G.
okay, so so if I'm going from the 25 here,
Yeah.
okay, little g is adjacent to 25, okay? If I was going from this angle down here, now this would be opposite and this would be adjacent. Does that make sense? Okay, so it depends on which angle you're using. I just chose to use this angle, okay? So here g would be adjacent to that angle because it's touching it. Okay, does that answer your question? Okay. Now, have we seen a problem like this? Do we know how to solve a problem like this once we have the equation written out? Yeah, what would we do to get g by itself here? We saw it last week. I know it's been a couple of days, huh? We slept a couple of times since then. We're going to multiply by 13, right? Get g by itself here. So now we're going to do not use -1 here. We're not looking for an angle measure. So that's when we're going to have to decide, when do I use -1 versus not using -1. This time we're just straight doing what we did last week, 13 times normal cosine of 25. Okay, what's that give me? 11.8, okay? And then the last thing that we're going to find is little h. Okay, if I go back to the 25-degree angle, what side would little h be from 25 degrees? Opposite. So now this would be opposite. Still got the hypotenuse here. I'm just using a different color so you can kind of see the two pieces that we're using. From 25, this is opposite, this is hypotenuse. O and H is sine, okay? So we're going to go sine of the angle that we're using the 25-degree angle, equals opposite over hypotenuse. We're going to solve it the same way. We're just using a different trig function this time. 13 times the sine of 25. Okay, what do we get here? 5.5. Okay, anybody need help with their calculator there? Okay, on this one here, we're going to keep going until the bell rings. I told you we may not get through all of this, but tomorrow we'll finish up what we don't get done today. What would be the easiest piece to find here on this triangle?
The measure of y being 38.
Yep, that's right. Because we already know 90 and 52. We know these three angles have to add up to be 180. So the easiest thing to do here would just take 90 minus 52 to get angle y. So angle y would be 38 degrees. Okay, so I'm going to try not to gum all this up so it's a little bit easier to identify what's going on here. Okay, the pieces that I would use here, I'm going to label this side little x. I'm going to label this side little z. Okay, because it's opposite of those two angles. From 52 degrees, what side would 8.5 be? Adjacent. This would be opposite, and this would be the hypotenuse. Okay, and it doesn't matter which one we find first. So let's say I wanted to find x first. Little x, okay? Little x is opposite the side that we know is adjacent. Okay, so we're going to use the side that we already know. So it's opposite and adjacent. Opposite and adjacent is which trig function? Tan. Okay, so we're going to do the tan of 52 equals opposite over adjacent. Okay, we'll finish that one up tomorrow. I went ahead and posted the assignment for 9-6. We're pretty much through it. We have a little bit to finish up tomorrow, and then tomorrow we have an activity as well. Okay, so try to start working through some of these. If you need help, come in and get some help, because this is different.
Mr.